Okay. All right, so here, it's just another data file. We have another frequency table, as you can see. Okay, here, hold on. Okay, right, what do? Again, same idea, right? So for the exam scores, right, we have 20, 16, 18, 19. Again, we don't have to list the data values one by one. We just multiply them by their frequencies. So for the mean, for the sum of the data values, we have 20 times 25, 16 times 30, 18 times 35, 19 times 40. That's what the sum of them are. Right? You could list them all one by one. You would have 20 listed 25 times, and those values alone, if you added them, you would get the same thing as 20 times 25. So you just multiply each data value by its corresponding frequency. Now, how many data values there are? Well, that's what the frequencies are, right? That's what the sum of the frequencies are. That's what the sum of them are. 25 plus 30 plus 35 plus 40. That's what the sum of them are. Okay? Good. Okay. So for the mean, we have 20 times 25, 16 times 30, the top here, which is equal to this, which of course is this sum. On the bottom here, right? That's the sum, that's how many numbers there are, the sum of the frequencies, which is 130. It's 130 data values. So for the mean, we do the top divided by the bottom, and we get this. That's the mean. So again, it's just the average. Now, this one was let you try, but if I remember correctly, the one I sent you, the notes I sent you had the solutions already. So let's just go to this. But again, it's really just the same idea. Is the mic on? Well, good. Good. Okay. I thought the mic was off. I'm sorry. But anyway, this is what we have here. So again, same idea. You multiply each data value by its frequency. 40 times 2, 12 times 31, 8 times 15, 91 times 52, right? See, that's how you get the sum of the data values. The number of data values, that's what this is, the sum of the frequencies. So so again, you get the sum, which is each number times its frequency, and you add up those products, which is this, divided by the sum of the frequencies, how many numbers there are, and you get this, which is this. So that's our mean. So mean is really just average. Now, that's not the only way, though, to specify what the center is. There's other ways as well. Namely, we have what's called the median. And that is the data value that's in the middle when the data is sorted or put in order from lowest to highest. You want to sort it from lowest to highest, smallest to largest. So to find the median, okay, what we want to do is this. So there is a process to find the median, actually. For one thing, you have to sort the data from smallest to largest. That's the first thing you want to do. What's nice is if you have something like Google Sheets, that can actually sort the data for you, which is nice. Okay. All right. Then, how do you actually get the median once you sort it? Well, it depends on how many data values there are. If there are an odd number of them, okay, an odd number of data values, then it's just the middle value in the traditional sense, okay? so if you have an odd number, if you have an even number though, or I mean, to get the actual data value, excuse me, if n is how many data values you are, okay, you take n, divide by 2, and you round it up to the next whole number. You always round it up. It's the number that's in that position. So n is how many data values there are, okay? You take n, divide by 2, round it up to the next whole number, and the number in that position is the median. If there are even number of data values, in that case, there really is no middle data value in the traditional sense. So what they do is they take an average. Namely, they get the data values in the n over 2 and n over 2 plus 1 positions. N is even in this case, so these will be integers as well. And then you take the average of the numbers in those positions. The whole point, remember, is that you want to have the same number of data values above the median and below the median. Again, this is when you sort it from smallest to largest. You want to have the same number of data values above and below it. All right, let's practice a bit. So let's say we had some quiz scores here, okay? And let's say we want to find the median quiz score. Okay, so what do? Well, for this data here, we want to sort the data. Okay, we want to sort it. So we sort it from smallest to largest, and this is what we do. Okay. So smallest to largest. So in this case, how many data values are there? Well, if you count them, it's 10. And it's even, right? There's 10 data values. Now, since there are 10 data values, that means the median is we look at n over 2, which is 5 and 5, right? And n over 2 plus 1 is 6. So the fifth and sixth data values. So 16 and 17. Again, I'm counting it from the bottom. You know, when they say position, they mean starting from the smallest number. So you have 16 and 17, but if you took the median of those, you would get 16.5. The mean of those, excuse me. So 16.5 would be the median quiz score. Notice that's not in the data set. That can happen. That is not in the data set. Okay, 16.5. Oh, whoops, sorry, wrong button. Okay, so that's what the median is. Again, it's a little more, you know, there is some calculation involved, but it's not terrible. Okay, so again, it just depends on how many data values there are. Let me get the other set of notes because I thought we'd be done by now, but we're not, but that's okay. We do this. Okay, that was the median. Example 1. Here we go. Median example 2. Let me just get those real quickly. Okay, I'm just going to get those and copy them onto the slide. We're not quite done yet. I thought we would be, but I was wrong, but that's okay. No big deal. Here we go. All right. Now, this one's a little bit different. Okay? I'll post the notes, don't worry. Why is this one different? Well, notice that we don't have the data listed out, right? We don't have that. What we have instead is a frequency table. Okay? So that's why it's a little bit different. We don't have the data laid out. I mean, you really, I guess, could list the data if you wanted to. These numbers aren't terrible, but what if the frequency was much higher? What if there was, say, I don't know, what if 4 was, say, 400 instead? And 1 was, say, 1,000. I mean, that'd be over 1,000 numbers you would have to list. I wouldn't want to do that. But what's nice is with the median, it turns out you don't have to. Okay, well, first, we want to know, are there an even number or odd number of data values? Well, that's easy to get, as I have written here. To get the total number of data values, right, you just add up the frequency. So in this case, we have 16 data values, right? 4 plus 1 is 5. Add 5, you get 10. Add 6, you get 16. And 16 is even. Okay, so normally, if we did have the data laid out, what would we do? We would have to get n over 2, which is 8, and n over 2 plus 1, which is 9. We have to get the 8th and 9th data values. Now, how do you do that? Well, you could sort the data in the left-hand column, but you have to keep the number with its frequency. Like 5 here is associated with 6. 5 is the smallest data value. So when you sort it, your 5 would stick with the frequency 6. Okay, now we're actually out of time. So I hate stopping in the middle of an example, but I don't want us to go beyond 11:50. So let's stop here. We'll just start with this example next time.